Okay. So today, 3rd of January, Happy New Year once again. So today we are going to try and complete chapter 10, whereby chapter 10 we are going to talk about the input-output system in a computer system. Why is this chapter 12? Let's stop at chapter 10. Okay, so chapter 10. We are going to look at the hardware, software, hardware input output of the computer system, the application, and how do we transform input output requests to hardware operations. And we are going to look at certain performance of each hardware and hardware each hardware in the computer system. So again, we are talking about the hardware and application, and we are also going to look at how to improve or how does the performance effect in the computer system. Okay. All right. So by you doing chapter 10, you are going to explore the input output of the subsystems inside a computer system. So what are the subsystems? The subsystems are input output are basically talking about the devices which are connected to your PC. Okay, so what are those devices? You have the keyboard, you have the mouse, you have the monitor, you have the motherboard, you have the RAM, you have the CPU. So these are input outputs which are connected to your PC. But if you're talking about the subsystems, subsystem means how are these devices connected to one another? Okay, because each device which is connected to the PC needs to be connected to each other. Why does it need to be connected to each other? It's simply because, for example, if you look at the keyboard, okay, so the keyboard needs to be connected to the CPU, needs to be connected to the RAM, needs to be connected to the monitor, because everything you type in on your keyboard is processed by the CPU and is stored inside the RAM and is also displayed inside the monitor. So these are all the connections. So we are going to see how these input outputs are connected and what is the architecture behind it. So that's why we need to look at the subsystems. And how complex is this connection? Because it looks simple, because whatever you type on your keyboard here, it appears on the monitor. But we need to understand how complex is this subsystem connection inside the input-output system. And last but not least, we are going to address the performance issues of this hardware and software, of this input-output hardware and also the software. Why is this performance issue important? Always remember, performance issues are important because it determines how fast, how slow your PC is working. So whenever you buy a laptop or desktop or whatever, you are or your mobile phone, you first want to see how big is the storage, okay, and then what kind of hard disk are they using, because from these two things you are able to determine how fast can the PC or mobile phone work, okay, because this is very, very important. For example, if you have a slow performance PC, meaning each time it boots up, it will take at least a 5-minute booting up session. 5 minutes in a booting up session is very, very long, because you have to on PC and you have to wait for the operating system to load. It takes time and to read all the files inside your hard disk. Okay, so these are important issues that you need to consider when, especially in purchasing a new laptop, desktop, or mobile phone. Right. So input-output management is a major component of operating system. Okay, we have highlighted that. Point number 3, various methods to control them. So there are various methods how to control these input-output methods. Okay, input-output management. Okay, and how each input and output device are connected between themselves is either you're using a port, bus, or device controller. Okay, bus is the simplest. Bus is something like a wire. Okay, but in a computer system, it's different. It's connected to one device to another device. Okay, ports, on the other hand, has a port. Each device is connected to a specific port. What is a port? It's a type of hard disk, and it's a type of hardware which has a specific address. So this specific address will get the data from a specific input-output device. And what is a device controller? A device controller can be considered as the driver which actually controls each input-output device, or each device which is connected to the computer system. So the device driver encapsulates the device details. Okay, that means whatever the device is carrying, connecting, transmitting, is all handled by the device driver. Okay, so input-output hardware. Point number 2, common concepts. Signals from input-output devices interface with computer, so it can connect through a port. What is a port? Look behind your PC, look behind your laptop, you will see several shapes and several shapes. So these are, some of them are HDMI cable ports, some of them are USB ports, some of them are VGA ports. So each port will actually connect with one particular device and carry some instructions or some information to be processed by the CPU. Okay, and then they are also connected through something which is called a daisy chain connection, or what we say is a shared direct access. What is a daisy chain connection? We'll come to that in the next slide. And we are also each input output is also connected through a PCI bus. Okay, so PCI bus, expansion slots. Okay, expansion slots are inside your PC, whereby each time you want to increase your RAM size or increase something, there are certain slots inside your laptop, inside your desktop. So you use this to increase the specification of your input-output device. And you also have a controller which actually controls each and every hardware which is connected to your PC. So a daisy chain, how does a daisy chain connection look like? It's simply like this. A daisy chain is a term that describes the ability to connect a series of devices together using a single connection between each two devices. So as you can see here, these are 3 devices, and each of them are connected through this specific connection, which is called the daisy chain. Input from here can be gone here and can be submitted here as well. So each of these connections is what we say as a daisy chain connection. Okay, this is a daisy chain connection, but once it gets here, you see there's it cannot go just one way like this. It has to go in and it has to come out. Okay, this is only going in, but there's no out, so you need to have a specific out as well. So these are another, or you say another way of a daisy connection. Maybe this is the input, okay, the electricity input, and these are output. That means let's assume these are connections to your laptop power. Okay, let's assume these are connections to your laptop power, or let's assume these are connections to your handphone. Okay, so these are power in and power out. So you can have the same thing but in a series format. Okay, so you can consider daisy chain as a series of connections. Okay, but in a typical PC bus structure, it looks like this. These are the hardwares, and they are all connected through a big PCI bus, and each of them are each is controlled by the this controller or the controller for each type of hardware, device controller. Okay, so you have the monitor, which has the graphics controller. You have the processor, which has the controller here as well, and which is controller to the memory. And you have these CSCI controllers, which are all controlling the hardware. So all of these controllers will get information from the devices and put it on this blue strip here, which is called the PCI bus. So this PCI bus will carry the information from one device to another device. Okay. Then you also have the fiber channel. Okay. This normally you can see behind your Astro, what do you say? Your Astro decoder box or your unified box. Okay. This input comes from a fiber channel, or what you say as, or you can say it as your unified, your fiber connections. Okay. So this is where the data is transmitted. Okay, data comes into fiber. Okay, fiber connection, and it's not commonly used in PCs. It's commonly used in network connection because it transmits data. Okay, and it transmits high-end. It transmits fast data. Okay, so that's why we have to learn about performance in this chapter, because data types are different based on the type of devices. Okay, so you cannot use this PC, you cannot use this fiber channel connected to your PC. Okay, because you need a certain type of hardware, a certain type of CPU to process this type of data, because this data comes in at a very fast speed. Okay, so each of these devices will have a specific port location. Okay, and this port will have a specific address. Okay, so these address belong only to a specific device. All right, so this address belongs to this belongs to this. You cannot interchange this address. Why do you need to know this address? Why do you need to know this address? Is simply because if you are doing some sort of programming and you need data taken from the game controller, or you need data coming in from the device controller, then you need to read the specific port. Okay, you need to read the specific port. This is where the data is coming out. Okay, it is something like, let's say you are in your class and you need to talk to someone in your class. Okay, you need to know that person's name, that person's ID number, or that person's phone number to specifically talk to him. So having the input-output range is something like having the phone number of a specific person in your class. Okay, if you would like to talk to me, then there are two methods of talking to me. You either know my phone number, okay, so that it's an address, or you can message me again through my phone number only. Okay, so my phone number is the specific address that you need to know in order to connect to me. All right, if you have a different address, then you will connect to a different person. Okay, so in the computer system, it uses this port address to get specific information from the specific device. All right, next we move on to pooling. So what is pooling? Pooling is something whereby the device, or in this case, an example is the server, is busy doing something else. So the data which is submitted to the particular device have to be it should be waiting until the server or the hardware or the device completes its job. Only then the new device can be going in. Simple example is by using the printer. If the printer is printing something else and you have just submitted a new request to print, then your new request is what we say as a pooling state. So the pooling state means it's waiting for something else to complete, and then it can complete its program. So for each byte of input output, that means for each byte of data inside an input-output, it must read everything to be processed. So before it starts being processed, it must read from the status register. The status register is inside the CPU, and the status register needs to know what is going on in the device. Because before, you have to remember, any process which takes place inside the computer system goes through the CPU and RAM. So the CPU is where this process is being processed, and once it's being processed, it will submit it to the device for further processing. Okay, so the pooling state is if the CPU has already released that job and now it needs to be completed. So it's waiting for something else to be completed, only then it can be completed. So it's waiting for the printer to complete its printing, only then the new printing job can come in. All right. So next we move on to the hardware situation. Okay, hardware situation. So the interrupt is whereby a series of sudden interrupt happens. So what is an interrupt? An interrupt can be a few types. One possible way is where there is no paper in your printer. Okay, so the point here is pooling can happen in 3 instruction cycles: read status, logic to extract status bit, branch if not 0. Okay, those are very complex things. Okay, so why does pooling happen? Pooling happens simply because the job cannot be completed when there isn't something else inside it. The printer, you cannot print your document because something else is being printed, so you have to wait. But if you have an interrupt, you can stop the current printing and you can print your interrupt. Okay, so CPU interrupt is always possible and is triggered by the input-output device. It could be if the printer if there is no ink or there's paper jam, so the printer will trigger an interrupt and will stop the CPU, and the CPU will handle it. So what the CPU needs to do is maybe the CPU comes up with an error message or any situation or any way it can help. Okay, so the interrupt will be handled by the CPU and to check what is going on, or at least come up with certain suggestions so that the user can know what to do. Interrupt vector, on the other hand, is an interrupt provided by this device, but it tells the CPU what to do. It is not like something that the device doesn't know, the device knows, but it gives a signal to the CPU telling the CPU, okay, now something is wrong, please do this. Okay, something is stuck, please do this. That is an interrupt vector. Interrupt vector and a normal interrupt are 2 different things. Interrupt vector informs the CPU saying that something is wrong on my side, and this is what is wrong. The normal interrupt does not know what is going on. It just informs the CPU something is going on, please handle it. That's about it. All right, next we go into direct memory access. What is direct memory access? Direct memory access is, as I explained to you just now, each process needs to go through the CPU to the RAM. Okay, so this here programmable input output, this is what we say the hard disk. So if the hard disk is supposed to be processed by the CPU, it needs to go into the RAM first, be stored, and then being processed. Okay, but in the direct memory access, since it's only going to the RAM, the data is transferred immediately straight into the RAM. Okay, so this takes less time to complete as compared to this. Okay, so why do we, in what situations do we use the direct memory access, and in what situations do we not use the direct memory access? If you have a large pool of data that needs to be processed, then you use the direct memory access, whereby the CPU knows that each data, or it's a large amount of data, and there is no need to tell the CPU what to do, so you just transfer So the operating system will handle this and transfer the data directly into the RAM without going through the CPU. Okay? So the operating system's job here is to transfer the data from the hard disk or where any inputs directly inside the RAM without going through the CPU over here. Okay, that is direct memory access. Okay, next we have the application input-output interface. What is this application input-output interface? Is an application software, and their interface, their inputs are coming from different types of devices. It may come from the keyboard, it may come from the mouse, it may come from a thumb drive, it may come from a USB scanner, QR code. So these are some applications, and what are those input output? Okay, so basic idea of an input output structure is something like this. Each of the device is connected to a controller, and this is the device here, right? So each of these devices has a controller, and this controller has a device driver. So in order for the operating system to handle any type of input, it needs to go through these three or these two process or these two structures. First, it needs to get it from the device driver, next pass it to the controller, only then it goes to the device driver. Okay, let's say I'm typing something on my keyboard now. Whatever I'm typing is being processed by the CPU. Okay, CPU says, okay, this needs to be submitted to the monitor. So the device controller will take it and give it to the device driver, and it appears on my screen. All right. So these are some characteristics of the device driver, IO devices, and how fast, how slow is it. Okay. For example, if we take the keyboard here, keyboard is shareable. Why is it shareable? Because you can use the same keyboard for multiple applications. Okay, you can use it, and then you have your, let's say, your CD-ROM. It's a random access. Yes, obviously it's a random access because you can access any file inside the CD-ROM anytime, and you don't have to go through one after another. You can just, how about the modem is always sequenced. So the modems, the connection comes in one after another, one after another. Okay. The disk block or the terminal, this comes in a block. Okay. That means this data which is transferred from the hard disk into the CPU comes in a block. Okay, one after another block. All right. So these are certain types of characteristics of the devices and their variation and their speed transfer. Okay. Okay. This looks at the performance of each device driver. Okay. So how does the computer system look at? Okay. So in order for you to, in order for the device driver to increase its performance, the network needs to be right. Okay, the network, that means how does a keyboard input output device sends information to the CPU. So it has to go through several steps. It has to go through a device driver, it has to go through a kernel, a user process, and then it appears on the screen. So it's, even though it looks simple now, so you type something on the keyboard and it appears on the screen. Okay, so these are certain major factors that needs to be considered when dealing with performance. Context switch, data copying, because certain data can be copied, so you need to have a good performance on your input-output devices. For example, you're doing Microsoft Word, copy, and then you want to save that same, whatever you copied to your PowerPoint, so you need something which is very, very fast. So you need the data or device controller to actually capture what you are doing, put it in the RAM, and then paste it in your PowerPoint. So these are important issues that you need to consider, right? And these are some how you can factors how you can improve your performance. How does the operating system, computer system improve performance? among which it's using the direct memory access, point number 4 here, or sometimes use smarter hardwares. Sometimes you can also increase your hardware, your hard disk space, your hard disk speed. So these are all improving factors, and these are some functionality of the device drivers that you need to know. This will be, you can just look at on your own as well. Okay, all right. So thank you so much for today. All right. So we have completed chapter 10. Okay. So again, chapter 10 looks at the input-output system connected to your PC. So we have looked at the device drivers. We have looked at how the application interface looks like. We've talked about the simple connection, which is the daisy chain, and we have also understood about the performance of each hardware and input-output device in your PC. Okay, all right. Do you have any questions to ask me?
I think so far so good, sir.
Sorry. All right. I'll see you in the next class. Thank you so much. Assalamu alaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, sir.
Salam.